Okay, so this is the worked out version of the quiz version A, and if you watch this video and get some of your questions answered about what you didn't know how to do on the quiz and want to try the redemption sheet, you can hand that in on Monday. If you look at the first question where I asked you to find the derivative by definition, then I did not want you to use any kind of a rule, a power rule, or anything, even a general power rule that you might know from another class. I want you to literally calculate the limit as h goes to 0 of the function evaluated at x plus h minus the function evaluated at x all over h. And in this case, then, that's the limit as h goes to 0 of the square root of 2 times x plus h minus 4. So I'm sticking x plus h in right here where the x is, and whatever I'm doing to the x, I'm going to do to x plus h. So I'm going to double it and take away 4. Minus, now I'm going to put the function just as I gave it to you, f of x, and again, this is all over h. So in order to calculate this limit, if I just try to plug 0 in, my numerator will go to 0 and so will my denominator, so that's not what I want to do. This is the type of problem where you want to use the conjugate. And the conjugate is the exact same radicals with a plus in between. So it's the 2x plus h minus 4 and the 2x minus 4. And the reason that you want to use the conjugate is now if I multiply my numerators by FOILing, when I multiply this first radical times itself, I end up with the radicand, which is 2x plus h minus 4. So 2 times the quantity of x plus h minus 4. So I get it freed from the radical. And then when I multiply the last ones, I get a negative 2x minus 4 in parentheses because it got freed from the radical. Now, that's only the first and the last, but I know that the outer and the inner are going to end up to be opposites of each other. So even if they're not freed from the radical, they're going to go to 0. So this will be my new numerator, and my denominator will have the h that it had before and the conjugate. Now I can distribute my 2 through and distribute my negative through. And when I do that, it turns out that this 2x has an opposite right here of negative 2x. So that's going to go to 0. This 2h does not have an opposite, so it's going to be up in the numerator. But this negative 4 now has an opposite of positive 4. So the only thing left in the numerator when I distribute and combine is that 2h. And in the denominator, I still have everything I had before. But now that this 2h is connected by multiplication, I can divide my h's out. And then I can actually take the limit. So I can send the other h to 0. And that's going to leave me with a 2 on top and a square root of 2x minus 4, because that's what this will become when the h goes to 0, plus another square root of 2x minus 4. Now, a common mistake on here was to add those two together by squaring them, but adding is not the same thing as squaring. When you add two radicals together, you get 2 of them. And so the addition gives you 2 times that radical 2x minus 4. And then to finally simplify, I could then finally divide out those 2's and I'd have my derivative by definition. Moving on, the biggest problem in section number 2 is not taking the time to rewrite your function and to look at it in a different way. So for A, you have to FOIL this out because we haven't learned any way that you can take the derivative of a function raised to a power. And we're going to learn how to do that on Monday, but when you took this test, this was your only option. And so that would lead you with your rewrite of your function to be 4x to the fourth minus 20x squared plus 25. And once it was rewritten, you could just simply use the power rule. Take the 4 and multiply by 4 to get 16. Drop the degree from 4 down to 3. Minus 2 times 20. Drop the degree from 1 down to, or sorry, from 2 down to 1. And that was it. For B, hopefully you realized, hey, I need the quotient rule there because this has 2 terms in it. But before you go and rush and do the quotient rule, remember that I said sometimes if you can factor the numerator and the denominator and one of the factors divides out, then you're going to have a simpler fraction to do the quotient rule on. And that's what you wanted to do. Now, if you went and did the quotient rule as it was written, nobody successfully simplified it as far as it could go. But if you did it correctly, other than the simplification, I only took off a half a point. But you wasted a lot of time too, so that might have had an effect later on your test. So the best thing to do on these is to factor the one that you can factor quickly, and then use that to try to see how to, maybe this will factor. And so if I use the t plus 1 and the t minus 3, then I can see that this foils back to that. So I took the time to factor it. I'm dividing out the factor that's in common so that I can say if t doesn't take on the value 1, then my function is just the same as this function. And I'd rather take the derivative of that. That's going to be simpler. So as long as I stay away from the number -1, I'll just do the quotient rule on this and end up with squaring the denominator, starting with that denominator, which is t minus 1, multiplying by the derivative of the numerator, and the derivative of t minus 3 is 1, minus the numerator times the derivative of the denominator, which is also 1. So then I can distribute a 1, which you really don't have to do because you're just going to get t minus 1, minus t minus 3. The parentheses mean that it's t minus t, so that's good, that's 0. But it's -1 minus -3, and that ends up being 2. So when you distribute your -3, you come up with your final answer for derivative. Moving on, C and D both required a rewrite as well. When this is a monomial, we talked about the fact that you don't need the quotient rule. And even though you could do the quotient rule, people weren't successful with it, or if you were successful, it took a lot of time. So you want to start thinking about these rewrites, especially if your algebra is not strong. You want to practice it a little bit. So the rewrite entails giving this denominator, which is a monomial, to both of the terms in the numerator. And so it's 4x to the fourth over 2x to the 1/2 minus 3x over 2x to the 1/2. And then you can simplify each fraction. 4 divided by 2, and x to the fourth divided by x to the 1/2 is when you subtract your exponents. So you get x to the 7/2. Here, 3 divided by 2 is going to stay 3 divided by 2, and 1 minus 1/2 is going to mean 1/2. So I haven't done the derivative at all. I just spent the time to rewrite because that time was well invested, because now I can use the power rule instead of the quotient rule. 7/2 times 2 is 7. Drop the degree by subtracting 1. 1/2 times 3/2 is 3/4. drop the degree to -1/2. So I'm subtracting 1 from that exponent. And then finally, make sure that you put the negative exponent down in the denominator of that fraction. Moving on to D. There was some confusion about how you simplify the cube root of 8. The cube root of 8 is not 8. The cube root of 8 is 2. So the coefficient here is 7/2. And the exponent on x is -1/3. Negative because it's in the denominator. 1/3 because it's a cube root. So that would be the rewrite, which makes your derivative as simple as -7/6 x to the -4/3. Dropping the degree 1 whole and using this to multiply by your constant multiple to come up with your new coefficient. And then just putting the x's in the denominator where they belong because they have a negative exponent. So that was the front page. On problem number 3, on the review sheet I said, make sure you know how to find the equation of a tangent line. So what I wanted to make sure that you knew the 3 steps and that you could apply the 3 steps to this problem. So step 1 was find the derivative, because that's the rule for the slope of the tangent line. So without it, I'm not going to be able to figure out the slope of this line I'm trying to write the equation of. So when I look at this, some people said, there's the product rule. It's x squared times the square root of x. Well, yeah, it is, but it also is x to the 5/2 power. So if you took a moment to rewrite it by adding your exponents, you could then just take the derivative with the power rule. 5/2 times 3 is 15/2, x to the 3/2. And you don't need the product rule. I don't have any problem with you using the product rule when you don't need it. The only problem is it takes more time. The second step is plug in x equals 4 to find the slope of your tangent line at this particular point when x is 4. So my slope is going to be f prime of 4, which is 15/2, 4 to the 3/2, which is 15/2 times, this is a square root, so 2 cubed, which is 8, and that's 60. And then the final step is to use point slope form. Y minus 24 equals that slope that I just found times x minus 4, and then I'm done. Number 4 was a culmination of a lot of things that we've done before and what I said on the worksheet about making sure if I hand you a demand function, you can write the profit function. So you needed to come up with the demand function, which is a P equals something with an X as a part of that something. It's a relationship between price and units. And once you got your demand function, then you needed to go to the revenue function by multiplying X times your demand. And then you had to go to your profit function by taking revenue minus cost. So coming up with the demand function, if I have my price for my tickets up here and the number of tickets down here as I'm graphing it, then I want to match a $34,000 X value with an $8 Y value, and a $24,000 X with a $12 Y. And what that's going to allow me to do is come up with a slope of this linear relationship between the two. And I said assume it's linear, so we can do that. So I'm going to subtract my Y values and put it over my x values subtracted in the same order. And that gives me negative 4 over 10,000, which is negative 1 over 2,500. So there's my slope. And I'll use this point to get my point slope, y minus its y value, slope times x minus the matching x value. I'm going to distribute, and because I want to move this 8 over there, so I want to have something it can add to. So it is negative 1 over 2,500 times x, and now I'm going to take negative 1 over 2,500 times 34,000. So I'm going to say 34,000 divided by 2,500 and get 13.6. It's positive because I'm distributing negative times negative. Now I can add the 8 over here and get 21.6. I'm going to call this P because I was trying to come up with the demand function, and price is my y value, my y variable. So I'm going to call it P instead of y, so that I can then flow right into my revenue function, which will be x times that. So negative 1 over 2,500 x squared plus 21.6x. And then I'll flow right into my profit function, which takes that revenue function and subtracts cost. Now to figure out cost, I got to look back up in my original problem for a variable and a fixed cost. So I'm going to subtract my variable cost, which means I'm going to take 0.2 times however many tickets I'm going to sell. And I'm going to subtract my fixed cost, which has nothing to do with the number of tickets I sell. So my profit function ends up being negative 1 over 2,500x squared plus 21.4x minus 85,000. And that's the end of B. Then I move on to letter C, which asked me to calculate P prime of 20,000. So I'm going to just rewrite my profit function. Take its derivative with the power rule. So I'm going to multiply and get negative 1 over 1250 x plus 21.4. And now that I have that, I'm going to plug 20,000 into it. So I'm going to say negative 1 over 1250 times 20,000 and add on 21.4. So I have 20,000 divided by 1250, and that's negative. So I'll multiply by negative 1 to make it negative 16. And then I add on 21.4 and end up with 5.4. What does that mean? The profit for the 20,000 first, the next unit that I'm going to make, is $5.40. So it seems like if I make that or sell that next ticket, then I'm going to make $5.40. Okay, it's not the profit for all of it, it's the profit for that next one. So you're hopping off of the curve onto the tangent line and trying to make an estimate of what's going to happen in the future. Finally, I had on the review sheet, I think I did the product rule in general. This is the quotient rule in general. So if I need to find h prime of anything, I want to write out what the quotient rule says. It says to take the function that's in the bottom and square it, start with that function, multiply on the derivative of the top function, the numerator, minus the numerator times the derivative of the denominator. That's the quotient rule that you have to have memorized. For the number 2 in particular, that means I need g of 2 squared. Well, if I don't know what g is, I don't know what g of 2 is unless somebody happens to tell me. G of 2 is negative 4. So I know then that this is negative 4 squared, even if I don't know what the function is. Then I need g of 2 up here, so that's negative 4. I want to multiply on f prime of 2 here, which is 5, minus f of 2, which is negative 2, times g prime of 2, which is negative 3. So I had all the information I needed. I just had to put it into the quotient rule and make a calculation of negative 20 minus negative 6, positive 6, sorry. Negative 2 times negative 3 is positive 6, over 16, which is negative 26 over 16, which is negative 13 over 8. And that is the end of the quiz. So hopefully that was helpful in explaining some of the questions you might have had, and you can use that to help you when you work on the redemption quiz, or redemption for the quiz 2.1 to 2.4, which I will be uploading to Angel shortly.